Relational AI makes it easy to go from data in Snowflake to an ontology to answering questions with reasoners that you could never answer with SQL alone. So what I've done here is I've loaded some of the new relational AI skills. And first, I'm just going to examine an ontology I built on supply chain data. So the agent is walking me through the ontology. We've got a number of concepts representing our supply chain network. We've got network structure represented in relationships. And so we can do different types of analysis on top of this. So let's see what sorts of questions we can answer on this ontology. I'm just going to nudge it to think in terms of solving our business problems. So we've got different types of problems we can answer. So what patterns exist in the network? So this would use our graph reasoning. What should we do? So optimization problems using prescriptive reasoning. And what needs attention, what's valid using rules. And we can also chain together different reasoners. So we could have graph feed into prescriptive, graph and rules have interplay as well. And so, yeah, optimizing allocation, I think that'll be a good topic for a future demo. But today, I just wanted to talk about one of these graph questions because I think that's a good end-to-end example. So let's see. Suppliers, influence, downstream impact, natural clusters. Yeah, so let's think about what sites are the critical connectors. So if a site went offline, let's say due to some sort of disruption, what might have cascading impacts, sort of bottlenecks in our supply chain. So now what the agent is doing is it's looking at examples, it's understanding the relational AI agent skills, and then it's going to use the relational AI in Python to generate a representation of the graph and select and run an algorithm, and then be able to generate a response as well. And this can all be incorporated back into the ontology too. So both this graph structure, the analysis output can all be incorporated back into relational AI. So let's see what it cooks up. All right, so we have constructed the graph, adding sites and operations, nodes and edges. We've got these different analyses for connectivity and centrality, and then we can combine them together. So let's go ahead and see what happens when we run it. We can see we're running these different graph queries based on the graph we constructed. Okay, so we were able to run these graph queries, and it sounds pretty technical, but if you break it down, really what we care about is what are the critical nodes in our supply chain network. And so we've got this factory and this distribution center, and they are the structural bottlenecks and they're influential. And so they would disrupt the network. So the agent is just explaining this in natural language using relational AI. And then we can look at the bottlenecks where disruption can cascade and the stack rank of influence. And so we can also look at differences in these analyses. So there isn't just one answer, there's some nuance. And so now that we understand this about the tech assembly factory, maybe we're going to go next to doing an optimization on the supply chain to try to reduce our supply chain fragility here, but balance that with cost and satisfying customer demand. That might be a next step, and this is an input into that. And like I said, you can incorporate this back into the ontology and keep building from there using the other reasoners as well. So let me know what you think and if you want to try it out.